In this video we are going to study exponents, actually powers of real numbers. And here there are some properties and rules it's going to be. And we are going to deal about these properties and rules. Here there are some information. Minus a to the power of n, if it is written outside of the parenthesis, and when it is written inside the parenthesis, they are different things. First we should understand that one, because here inside the parenthesis, when we have minus a times, actually it's explaining here minus a times, a, but all they are positive. And with respect to this one, the result is going to be equal to negative again. And I said positive, but with respect to a we are talking. And a times a multiplied by itself, then we are putting minus sign. But here, in the second one, since it is outside of the parenthesis, this power is outside of the parenthesis, we are multiplying minus a by itself n times, and the result will be positive or negative, because we learn like this at integers topic. Minus a to the power of n, if n is odd number, the result will be negative. If n is even number, result will be positive. Here a times x to the power of n and a times x to the power of n, they are different terms. When we multiply outside and inside, it's explaining actually that one here, and it explains the difference between them here. Okay, now I'm going to solve some exercises to understand these differences. X times x times x, we know that it's going to be equal to x to the power of 3, or for the, this is for a. For the b1, it's going to be, here I'm going to use different color. For the b1 minus 3 times minus 3 times minus 3, which is equal to minus 3 to the power of 3. Since the power is odd number, we are going to get a negative result. Negative power of integer, it's going to be odd power of negative integer. Sorry, I made a mistake. Odd power of negative integer, it's going to be negative. So it's equal to 3 to the power of minus 3 to the power of 3, which is equal to minus 27 going to be. Okay, the next one, it's going to be minus 2 to the power of 4. So even power of negative number, it's going to be positive. The result, it's going to be positive 2 to the power of 4, which is equal to 16. It must be. Here 8 times a times a times a times b and b and b. Here a and b, they are different terms. That's why we cannot multiply by each other. That's why we need to write them differently. I'm going to write here 8 times a, there are 4 a's, so a to the power of 4, and there are 3 a's, and b to the power of 3, we should separate like this. Here x, 27 and 16, they are different terms. We can write as a prime numbers. These are 16 and 27, and here it's going to be equal to, again I'm going to use 16 is equal to 2 to the power of 4, x times x is equal to x squared, and 27 is 3 to the power of 3, and y is equal to y to the power of 3. It's going to be, because y multiplied by itself 3 times. And the last one, I'm going to choose blue color for that one. Here we have one minus, and the rest of them, they are positive. So minus times plus times minus times plus minus times plus. So we are going to get always the results minus, because there is only one minus sign, and we can say when we multiply by negative numbers, always the results, they are going to be negative. So the f1, it's going to be minus z to the power of 4. Okay, here there are some properties. a to the power of m times a to the power of n when the bases are same at the powers. When the bases are same at the powers. So 5 to the power of 2 times 5 to the power of 3, it's going to be equal to 5 to the power of 5. And 5 to the power of 4 to the power of 5 times 4 to the power of 1. When the power is not written, we know that it's invisible power. 4 to the power of 5 plus 1, which is equal to 6, it's going to be. And I'm going to do this one, the negative one. The negative, it's not important because the bases are same. Minus 3 to the power of 5, it's going to be minus 3 to the power of 2 plus 3, which is equal to 5 is the answer going to be. Okay. The next one, if we have multiplication inside the parenthesis and then exponential expression, it means that you can distribute the power to the both number. I'm going to write this is going to be equal to 3 to the power of 3 times 5 to the power of 3, or this is the inverse of it, 2 to the power of 4, 3 to the power of 4 when the powers are same. If the bases are different, you can write under the 2 times 3 to the power of 4, it's going to be, and 2 times 3 is equal to 6, 6 to the power of 4, it may be. 16 times 2 is equal to 16 to the power of 2 to the times 2 to the power of 2, it's going to be, and the other one, it's going to be exercise for us. Here, this is called power of power. When we have power and outside of the parenthesis, again power. Power of power is multiplication of power. Power of power is multiplication of power. You can note down this one. Power of power is multiplication of power. And here the answer is going to be 2 times 2 to the power of 3 times 2, which is equal to 2 to the power of 6. Or this one is minus 3 to the power of 4 times 2, which is equal to minus 3 to the power of 8. And when the power is even number, you can solve the question with positive answer. Here 8 to the power of 4 and 8 to the power of 3 times 4, it's going to be equal to 12. And the last one, it's going to be homework for us again. Here we studied this one at rational numbers part. You can distribute the power to the numerator and denominator. Actually, this is equal to 4 to the power of 4 over 5 to the power of 4. Pardon, the power is 3. So it's going to be equal to 4 to the power of 3 times 5 to the power of 3, or 8 to the power of 5 over 2 to the power of 5 times b to the power of 5, because for the multiplication also we are doing the same thing. And here x to the power of 4 over y to the power of 4, 3 to the power of 4, it's going to be y to the power of 12, because when you get power of power, this we are going to get multiplication of powers. Here the negative power of the rational number, numerator changes the place of numerator and denominator, so this becomes like this, 4 over 3 to the power of 2, which is equal to 4 to the power of 2, 3 to the power of 2. Since the numbers are smaller, I'm going to find the values of it. 16 over 9, it's going to be. Or 8 to the power of 3 over b to the power of 2 to the power of minus 4 means b to the power of, sorry, I wrote 6. b to the power of 2 to the power of over a to the power of 3 to the power of 4, which is equal to b to the power of 2 to the power of 4 over a to the power of 3 to the power of 4, which is equal to b to the power of 8 over a to the power of 12, it's going to be. And when we have the base same, we are going to subtract the powers if there are exponential expressions like this. Here a to the power of m over a to the power of n is equal to a to the power of m minus n. When the powers are same, if we have division, we should subtract it. When the bases are same, with different powers and division, we should subtract the powers. So this is going to be equal to a to the power of 5 minus 3, which is equal to a to the power of 2. It's going to be, or this is here, x and x, y and y, they are going to do, we are going to do operation together. X to the power of, the power is 1 here, 2 minus 1, times y to the power of 3 minus 2 it's going to be. So x to the power of 2 minus 1 is equal to 1, which is not written, and y to the power of 3 plus 2, because minus and minus 2, it's going to be plus 2, which is equal to x times y to the power of 5 it's going to be.